Imagine this. In the black sea of interstellar space where no sunlight reaches, something moves. Not drifting, moving. With direction, with speed, and with a strange, deliberate silence. For billions of years, it wandered unseen between galaxies, its icy surface scarred by radiation older than the Earth itself. Until one night, a telescope in Chile caught a flicker of motion, a glint of light that shouldn't have been there. That moment changed everything, because this object wasn't one of ours. It wasn't a comet from our solar system. It wasn't even born from the same star as us. It came from somewhere else, from another sun, another home, and it was coming here. They called it 3I Atlas, the third interstellar visitor ever recorded by human eyes. Before it, there had been two others, Oumuamua, the slender, spinning mystery of 2017, and Borisov, the gas-spewing traveler of 2019. But 3I Atlas, it's different, older, faster, and perhaps the most revealing messenger yet. When astronomers first plotted its trajectory, they realized it was slicing through our solar system at nearly 58 kilometers per second. That's about 130,000 miles per hour. So fast that no gravitational pull, not even the sun's, could capture it. It came in, danced through our cosmic neighborhood, and will leave us forever, vanishing back into the endless dark. But before it goes, it leaves behind something extraordinary. Clues, patterns, echoes that might tell us how life began. The story of 3I Atlas begins with a flash no one expected. At the Atlas Observatory in Rio Hurtado, Chile, a set of telescopes designed to look for dangerous asteroids saw something faint, distant, and moving too quickly for anything local. At first, researchers thought it was a data error, a miscalibration, a ghost image. But within hours, cross-checks came from observatories in Hawaii and Spain. The coordinates matched. This thing was real, and it was approaching Mars. Within days, headlines spread across the scientific world. New interstellar object detected for astronomers. It was like déjà vu, a reminder of the day Oumuamua broke into the news, when theories about alien probes and cosmic artifacts flared up overnight. But unlike Oumuamua, 3I Atlas wasn't shy. It glowed. It emitted gases. It behaved like a living, breathing comet. Only it didn't act quite like one. Its coma, the glowing halo of dust and gas around it, was unusually bright compared to its core. Its tail twisted in directions that defied solar wind patterns, and its brightness fluctuated, sometimes too much, almost as if something inside it was changing. To grasp the scale of what you're hearing, think about this. 3I Atlas could be older than our sun, somewhere between 3 and 11 billion years old, meaning it might have formed back when our Milky Way galaxy was still young, still colliding with its neighbors. The dust on its surface might be the same dust that once drifted through the first stars ever born. You're not just looking at a comet, you're looking at a memory, a frozen message from the dawn of everything. And yet the closer we look, the stranger it becomes. NASA's Transiting Exoplanet Survey satellite, TESS, picked up traces of 3I Atlas months before it was officially detected. When scientists went back and analyzed the data, they realized the object had been glowing faintly long before it should have started reflecting sunlight. That means it was already active, releasing gases, interacting with something, perhaps even reacting to heat that wasn't there yet. That shouldn't happen. Not in the cold vacuum beyond Jupiter. Imagine standing outside on a winter night and watching a snowball start to melt in your hand, even though the air around you is below freezing. That's what 3I Atlas was doing, melting where it shouldn't, shining where it shouldn't. And that's why scientists are so obsessed with it, because every rule it breaks is a message about what we still don't understand. They trained the Hubble Space Telescope on it in July 2025 and later the James Webb Space Telescope in August. The images stunned everyone. Instead of a single bright core, they found a complex structure, a twisted mass of ice dust and gas jets firing from beneath its crust. The more they looked, the less sense it made. As one astronomer said, it's like watching a candle burn in reverse light emerging from cold instead of heat. By now, you might be wondering, why does this matter? It's just another comet, right? But here's the thing. Every interstellar object we've ever seen is a messenger from a place we can't yet reach. They come from systems with different stars, different chemistries, different rules of planetary birth. Studying them is like finding fossils from another universe's creation. And this time with 3I Atlas, we're closer than ever to understanding what those fossils mean. Scientists from Harvard JPL and the European Southern Observatory are tracking its chemical signature carbon monoxide cyanide hydrogen, all slowly leaking into the void. Some of these molecules are prebiotic, the same compounds that once seeded life on Earth. If 3I Atlas was forged around another star, then it carries the chemistry of an alien dawn. And if those molecules match ours, it suggests something profound, that life might not be an Earth accident. It might be a cosmic habit. You begin to realize every comet, every meteor, every grain of dust could be part of a universal conversation that's been happening for billions of years. Maybe 3I Atlas isn't just a traveler. Maybe it's a memory the universe is trying to return. And as it moves past Mars, bathed in sunlight for the first time in eons, it leaves a faint green shimmer in its trail, a signal perhaps, or just a beautiful coincidence. Either way, it's enough to make us look up and remember how small we are, and how lucky we are to witness something so impossibly ancient, so impossibly alive. The telescopes are still watching, the data is still streaming in, and this is only the beginning. Because what scientists will find next might change how we think about where we come from, and what else might be out there looking back. You remember that first glimpse of 3I Atlas, the silent traveler cutting through the solar dark. But what scientists found when they looked closer defied almost every expectation they had. It wasn't just another icy wanderer. It wasn't behaving like a comet at all. It was breaking the rules one after another. When Hubble and Webb both turned their eyes toward it, they caught something extraordinary. You'd expect a comet's tail to stream away from the sun, driven by heat and solar wind, but the tail of 3I Atlas pointed toward it. It was like a candle flame bending backward, as if the sun's light were pulling it closer instead of pushing it away. The first reaction from NASA's data team was disbelief. Dr. Martin Cordner, an astrochemist leading the analysis, reported that the gas surrounding the object, its coma, wasn't made primarily of water like every other comet we've ever studied. Instead, it was rich in carbon monoxide and carbon dioxide, even though it was far too cold for those gases to behave that way. Something about the object's chemistry was rewriting the textbooks literally overnight. Hubble measured its size. The nucleus, the solid heart of the object, is no more than 5.6 kilometers across, smaller than scientists first assumed. But it was bright, far too bright for its size. The glow didn't make sense. It was as if the entire comet was alive, reflecting more sunlight than it should. Some thought it might be covered in reflective ice crystals. Others proposed that the brightness came from the way dust was being ejected, not evenly, but in unpredictable bursts, almost like breathing. Every few hours, its light pattern shifted slightly, as if something inside it was rotating, pulsing, responding. And the strangest thing? It wasn't random. The changes followed a rhythm. 16 hours, then 29, then back again, almost like a heartbeat. Astronomers using the TESS telescope went digging through old data and found that 3I Atlas had already been glowing months before it was officially discovered. They estimated that its brightness had increased 5 times faster than expected, not by reflecting sunlight, but by generating energy from within. It wasn't just reacting to the sun. It was doing something more complex, as if it carried a source of power deeper inside, something ancient, something intentional. Now, let's be clear, no one's saying it's alive. But whatever process is happening inside 3I Atlas doesn't match any natural model we know. Think about that for a moment. This object came from another star system, and yet it behaves in a way that doesn't even make sense within its own physics. If that doesn't make your mind spin, nothing will. On August 6, 2025, the James Webb Space Telescope recorded the most detailed infrared spectrum of 3I Atlas yet. The data revealed a mix of gases no one had ever seen from a comet this far out. It was venting compounds that usually appear only after an object gets close to the sun, and it was doing it way out by Mars. That shouldn't be possible. To give you a sense of scale, most comets begin waking up around 3 astronomical units from the sun. 3I Atlas was active at 6 AU, nearly twice that distance. It's as if a frozen rock in deep space suddenly decided to warm itself up. And so the question arose, what could trigger this? Dr. Karen Meech from the University of Hawaii described it perfectly. This comet doesn't just react, it anticipates. It starts to move before it's touched. Her team proposed that volatile elements, perhaps nitrogen, hydrogen, or even exotic ices from another star system, could be responsible. But there's another theory, one that keeps resurfacing. The idea that maybe, just maybe, 3I Atlas isn't entirely natural. Now, before you roll your eyes, hear this. In 2017, when Oumuamua was first discovered, it too behaved in ways that made no sense. It sped up without any visible jets of gas. It rotated erratically, reflected light unevenly. Harvard physicist Avi Loeb famously suggested it could be a piece of alien technology, perhaps a defunct probe drifting for eons between stars. His paper was controversial, but it opened a door. And now, with 3I Atlas, that door just creaked wider. Loeb pointed out something fascinating. The odds of finding 2 interstellar visitors within a single decade were astronomically low, unless our galaxy was full of them. And if there are many, then what are they doing here? NASA and the European Space Agency remain cautious. Their official stance, 3I Atlas, is a natural body, just an unusually volatile one. But deep down, even the most skeptical scientists admit that it's strange. Very strange. When analyzed for light polarization, the way sunlight scatters off its dust, 3I Atlas produced a negative polarization signature unlike anything we've ever seen. Not even Borisov, not even Oumuamua behaved like that. To put it simply, the light isn't bouncing off this thing normally. It's bending, twisting, as if the surface has a structure, something fine, deliberate, perhaps engineered. But again, no one can prove that yet. And that's what makes it so intoxicating. Every time a telescope captures a new frame, every time a computer refines a trajectory, it leaves us with more questions than answers. Is it a comet? An ancient shard of a long-dead planet? A piece of cosmic machinery? Or simply a mirror showing us how much we still don't understand? And here's the part that hits hardest. If 3I Atlas really is billions of years old, then it has seen galaxies collide. It has watched stars be born and die. It has passed through regions of radiation so intense that no life could ever survive, and yet it endures. Every tiny scar on its surface is a timestamp in cosmic history. And maybe, just maybe, it carries within it the blueprint of creation itself. NASA's newest models suggest the material making up 3I Atlas contains amino-like compounds, the precursors of life. If confirmed, it could mean that interstellar travelers like this one have been sowing the seeds of biology across countless worlds, including ours. The idea is ancient, called panspermia, but now for the first time, we might actually be seeing it in action. So the mystery deepens. An object that shouldn't exist behaving in ways that defy physics, carrying chemicals that could spark life. And all of it right now passing quietly through our own neighborhood in space. You can almost feel the irony, can't you? That something older than time itself is drifting by while most of humanity doesn't even know it's there. But for those who do, for those looking up tonight through their telescopes, it's a reminder. The universe still holds secrets that even our most advanced science can't quite explain. Not yet. The story of 3I Atlas is just beginning. And the next revelation might come from the unlikeliest of places, not from the great space observatories, but from a small cluster of telescopes on Earth that caught something no one expected. A signal, a pattern, a pulse. It began with a flicker, barely noticeable at first, a subtle shimmer buried in a pile of telescope data. A pattern so faint it could have been dismissed as noise. But the thing about noise in the universe is Sometimes it's trying to tell you something. Late September 2025. At the Cerro Paranal Observatory in Chile, a team of astronomers from the European Southern Observatory was cross-referencing data from Hubble James Webb and a handful of Earth-based radio telescopes. Their mission was simple: measure the brightness of 3I Atlas as it approached its October perihelion, the point closest to the Sun. But what they found wasn't a steady curve of brightness. It was pulsing. Every 11 minutes, the intensity of light from 3I Atlas rose and fell in perfect rhythm. That shouldn't happen. Comets don't pulse. They don't flash in regular cycles. They tumble, they reflect, they glow, they fade, but they do not beat. And yet there it was, a silent rhythmic signal echoing through deep space. At first, the scientists assumed a software error, maybe atmospheric interference or cosmic rays corrupting the sensor array, but after cross-verification, the pattern held, not just from Chile, but from the Subaru telescope in Hawaii, and even the European Space Agency's Gaia satellite. 3 instruments, 3 vantage points. Same result. Something on or around 3I Atlas was pulsing. The next step was to analyze it. The pattern wasn't random. It had structure. Rises and falls with consistent amplitude, decaying, then repeating again like a beacon. But the frequency didn't match any known type of rotational period or jet behavior. It was too precise, too consistent. Natural systems, as astrophysicist Dr. Mei-Lin Zhao once said, are messy. They breathe irregularly. This one doesn't. By early October, scientists were calling it the pulse. It wasn't a radio signal, not in the traditional sense, but buried within the light itself in the polarization data and the spectral intensity curves was a kind of modulation. Think of it like Morse code, not in sound, but in photons. And it wasn't the first time something like this had been recorded. Back in 2019, a faint repeating optical signal was reported near the trajectory of Comet Borisov. It turned out to be solar interference. But this was different, because the pattern from 3I Atlas was repeating across multiple wavelengths, visible infrared and ultraviolet. That's almost impossible to explain naturally, unless of course you consider the unthinkable. When the Harvard-Smithsonian Center for Astrophysics got involved, Dr. Ava Reinhardt, a researcher specializing in photonic communications, proposed something bold. If a civilization wanted to send a message across interstellar distances, light would be the most efficient carrier. It doesn't decay like sound, and it can embed data within modulation frequencies. If you found a natural object, a comet, perhaps you could use it as a relay. Her words stirred a firestorm online. Headlines flared: alien beacon in 3I Atlas, interstellar object transmitting data. Of course, NASA dismissed the theory immediately. No confirmed evidence of intelligent origin, they said. Just coincidence. But the more they tried to explain it away, the more the mystery grew. Because even if it wasn't intelligent, the physics still didn't add up. By mid-October, as 3I Atlas drew closer to the Sun, the pulse became stronger. Its amplitude increased by nearly 30%, and the light modulation became clearer, not fading but evolving. Some parts of the spectrum began splitting into harmonics like musical overtones. Astronomers called it resonant scattering. But one scientist, Dr. Lionel Rivas from ESA, offered another interpretation. The pattern is self-similar. It repeats fractally. That's a hallmark of design or of feedback. Imagine waves colliding and amplifying themselves in perfect synchronization. That's what the data looked like. As if something inside 3I Atlas was resonating in response to solar radiation, like an instrument being played by the light of the sun. Could it really be a machine? An ancient probe drifting for billions of years, built by someone or something long before us? That's the question that haunted the scientific community. Most experts still resisted. They argued that exotic ice compositions or self-shadowing patterns might explain the periodic flashes, but none of those models could reproduce the exact timing of the 11-minute pulse. And then something changed. On October 19th, the Gemini South Telescope recorded a sudden spike, a doubling of the light intensity for exactly 1 cycle. Then it returned to normal. A glitch. Maybe. But what made it eerie was that the timestamp matched precisely with an observation window from NASA's Deep Space Network in Canberra, Australia. For those exact 11 minutes, one of NASA's receivers was locked onto 3i Atlas testing new tracking software. No one expected to get anything back, and yet for a fraction of a second, the receiver picked up a faint burst in the X-band frequency. The data was inconclusive, too weak to decode, but the timing was perfect. Online, it spread like wildfire. Reddit threads, YouTube breakdowns, scientific Twitter lighting up with one question: did 3i Atlas just respond? NASA denied it, of course. They always do. But the data file, a small, corrupted stream of binary static, was leaked anonymously to a public astrophysics forum. People ran analyses, spectrograms, FFT decompositions. And inside that chaos of numbers, they found something bizarre, a repeating harmonic series matching the hydrogen spectral line, 1420 MHz. That's the universal call frequency used in SETI, the search for extraterrestrial intelligence. Coincidence? Maybe. But for many, it was enough to believe that somewhere out there something was speaking. And for a fleeting moment, we might have heard it. Of course, no one could confirm it. The data's too fragmentary, too easy to dismiss as an artifact. But what it did confirm is that 3i Atlas isn't just a rock drifting in space. It's doing something, interacting, responding. And that's what terrifies people the most. Because if it can respond, then it can detect. If it can detect, then it can decide. And what if we're the ones being studied? As the comet moves past perihelion, it'll begin to fade its light, dimming its pulse, growing weaker. Maybe the heat of the sun will tear it apart. Maybe it'll shatter, releasing secrets we'll never understand. Or maybe it'll just go silent again, leaving behind only a whisper in the static and a trail of numbers we'll spend years trying to decode. But whatever happens, for one brief window in time, humanity looked into the void and saw something looking back. And perhaps that's all the confirmation we'll ever need. As the world's attention shifts, a new player enters the scene. Not a telescope this time, but a spacecraft one that's been quietly watching the stars for years and has just begun to pick up something eerily familiar. A pulse. Not from 3i Atlas, but from somewhere else. When the pulse faded, the silence didn't return. Instead, the silence began to hum. It was faint, softer than a whisper, quieter than the static between stars, but it was there. And this time, it wasn't light. It was dust. Tiny ancient particles drifting through the void, each one carrying a trace of memory, a record of everything it had ever touched. Scientists at the European Space Operations Center noticed it first. Their deep space instruments designed to monitor cosmic dust flow near Mars were detecting something unusual, a cluster of dust particles moving against the solar wind. That's not supposed to happen. Solar wind, the continuous stream of charged particles from the sun, pushes everything outward away from the star. Nothing comes inward unless it has help. The reading suggested a dust plume originating near the trajectory of 3i Atlas and moving with a strange rhythm like an echo of the comet's pulse. It wasn't random turbulence, it was organized. For weeks, astronomers debated what could cause it. Some argued it was electromagnetic interference, charged particles trapped by the comet's magnetic tail, but others saw patterns too precise to be natural. Dr. Julian Harkness of the Max Planck Institute for Solar System Research described it best. It's like the dust is listening, responding to a signal we don't understand. Theories multiplied. Was it a coincidence, or was the dust millions of microscopic fragments acting as a distributed antenna? NASA's Parker Solar Probe was the first to investigate. In mid-October, as it swept through the inner heliosphere, its dust impact sensors registered a spike thousands of microcollisions per second. But embedded in the noise was a repeating signature. Every 11 minutes, just like before. Scientists were cautious. Patterns can trick the mind. But the timing matched 3i Atlas's pulse perfectly. The probe's instruments detected tiny variations in the electrical charge of dust grains fluctuations that appeared synchronized. Dust doesn't synchronize, said Dr. Aisha Patel, lead plasma analyst for the mission, unless something is making it. She wasn't alone. The Solar and Heliospheric Observatory SOHO reported similar findings: faint ripples in the solar wind's magnetic field propagating outward from 3I Atlas's path. It was as if the comet had left behind a trail of information, encoded not in radio, not in light, but in the dust itself. Meanwhile, back on Earth, a different kind of researcher noticed something even stranger. Dr. Ren Ito, a physicist working with the ALMA array in Chile, was analyzing terahertz data of interstellar dust spectra when he found anomalies in the reflection patterns. Under normal conditions, cosmic dust reflects infrared light uniformly, but these samples fragments believed to originate near the comet's tail displayed oscillations, structured oscillations, like interference fringes. "Imagine if someone whispered into the dust," Dr. Ito said in an interview, "and it remembered the whisper." His team reconstructed the data as a 3D waveform. The result looked almost musical, a rising and falling pattern that mirrored the earlier light pulse. The hum of 3I Atlas was now written into the dust itself. As the data poured in, one phrase began circulating online the dust network. Because when plotted across 3D space, the dust wasn't random at all. It formed a lattice, a vast invisible structure stretching millions of kilometers behind the comet, like the wake of a ship cutting through the cosmic ocean. At first glance, it resembled a magnetic field map, but under deeper analysis, the distribution of dust density matched the golden ratio spiral, a logarithmic curve found in galaxies' Shell's hurricanes, and apparently the trail of 3I Atlas. Coincidence maybe, but no one had ever seen a comet leave behind geometry. By late October, just before perihelion, ESA's solar orbiter captured the first detailed image of the phenomenon. What it saw stunned everyone. Instead of a simple tail of dust, 3I Atlas's wake looked like a woven web strands of luminous filaments interlacing and bending in rhythmic symmetry. Each thread flickered faintly with reflected sunlight, as if alive. The image went viral. Some saw art, others saw design. A few whispered one word: architecture. Because as Dr. Karen Meech once said, nature doesn't weave perfectly symmetrical dust, but science demands caution. NASA's Jet Propulsion Laboratory ran simulations to recreate the shape of the tail using radiation pressure, solar wind, and outgassing effects. They managed to mimic parts of it, but not the synchronization. The flicker in the dust strands remained unexplained. So they did something rare. They turned to pattern recognition AI. Using neural models trained on thousands of cosmic phenomena, the AI was asked to classify the 3I Atlas dust data. It returned one label, one that didn't exist in any database. Signal artifact, unknown origin. It was then that scientists realized something bigger. The pulse wasn't gone. It had simply moved from light to dust. And if dust could carry information, it could carry memory. Every collision, every orbit, every interaction between sunlight and cosmic debris creates micro changes in charge and spin. In theory, those changes could encode patterns, a primitive form of storage. So when the dust echoed, it might not have been sound at all. It might have been data. And that's when the question changed. For months, scientists had been asking, what is 3I Atlas? But now they began asking, what is it saying? If the dust wake carried data decoding, it could reveal information older than our sun. It could tell us where the object came from, or even what built it. Agencies began quietly assembling joint teams, NASA, ESA, JAXA, and private groups like Breakthrough, listened to develop algorithms that could parse electrostatic signatures from the dust patterns. But time was running out. 3I Atlas was already fading from sight, drifting behind the sun. The last transmission from the Parker Solar Probe recorded one final faint variation, the hum dropping in frequency until it matched the Schumann resonance of Earth itself, 783 Hz, the same frequency the human brain emits in a calm, dreaming state. Coincidence? Maybe, but some say the universe was whispering in a language we could finally understand. For now, 3I Atlas is gone, hidden behind the brilliance of the sun. But its echoes remain drifting through the solar wind, weaving patterns of light and dust and silence. And maybe when the dust settles, we'll realize we weren't listening to a comet at all, but to the faint heartbeat of a universe trying to remember itself. Light has no memory. That's what we were taught. It travels, it illuminates, it fades, but it doesn't remember. Yet as we trace the fading echoes of 3I Atlas, a strange idea began to emerge in the minds of physicists. What if light remembers everything it touches? Because after the dust stopped pulsing, after the instruments fell quiet, something else began to appear, not in the sensors of spacecraft, but in the reflections of light itself. In late October, just days after 3I Atlas disappeared behind the sun, a small team at the European Southern Observatory in Paranal, Chile, pointed their spectrometers toward Mars, trying to capture the last glimmers of sunlight reflected off the comet's trail. What they found made no immediate sense. The spectral signature of that sunlight was altered. Tiny deviations, microscopic phase shifts in the coherence of photons reflected from the dust. It was as though the light had passed through something that refracted memory itself. Normally, when light bounces off cosmic dust, the scattering is random, directionless. But this was structured. The photons carried a pattern, a repetitive waveform, as if something had written on them. Dr. Emilia Novak, lead optical physicist on the team, said it best. It's as though the dust didn't just reflect the light, it recorded it. This shouldn't be possible, at least not in classical physics. But quantum optics tells us that photons can store information in their phase, their polarization, even their entanglement state. So, what happens when sunlight, ancient, scattered, reborn from countless stars, meets a field of interstellar dust carrying the remnants of an alien object? It writes history in light. NASA's James Webb Space Telescope confirmed it days later. Using its near-infrared spectrograph, JWST captured residual photon interference patterns in the comet's wake, displaying rhythmic variations matching the earlier 11-minute cycle found in the dust. In other words, the same pulse that began as light traveled into dust had now returned to light again. It was a perfect feedback loop, the universe remembering itself through reflection. Around the same time, a team of astrophysicists at MIT Kavli Institute decided to take the data further. They mapped the light phase interference from the JWST images onto a 3D projection model. When rendered visually, the pattern resembled something almost biological, a spiral of energy folding into itself like DNA made of photons. The scientists jokingly called it the genome of light. At first, it was just metaphor, but the deeper they analyzed the pattern, the more it resembled information encoding. The intervals between pulses were not random. They followed a binary rhythm, structured, repeatable, deliberate. Could 3I Atlas have been carrying light-based data, or was it just the universe's natural way of preserving its own history, one reflection at a time? The question wasn't new. Decades ago, quantum theorists had proposed that information could never be destroyed, only transformed. It's called the law of quantum information conservation. Everything that happens, every photon that bounces, every atom that collides, leaves an imprint somewhere in the fabric of reality. Maybe as 3I Atlas crossed the solar system, it simply awakened what was already there, a dormant archive of light waiting to be read. In early November, a collaboration between the European Space Agency and NASA's Goddard Institute developed an experiment to test this theory. They recreated the dust field composition from 3I Atlas in a vacuum chamber, then directed a laser through it. The scattered light didn't just reflect randomly, it bent in repeating arcs, almost as if the dust knew what to do. And in that interference pattern, they detected faint harmonic oscillations, frequencies resonating at exactly 7.83 Hz, the same Earth resonance recorded by Parker's solar probe weeks earlier. Coincidence maybe, but it suggested that light and dust were interacting through a deeper hidden layer, a universal frequency connecting all matter. Some began calling it the photonic memory field. Dr. Ren Ito, the same physicist who had first described whispers in the dust, believed that 3I Atlas's trail acted like a waveguide, channeling electromagnetic energy through structured dust. in his words. It's as if the universe is speaking in light and the dust is its recording medium. His papers gained traction even outside scientific circles. Philosophers and theologians began debating what it meant for light to remember. If photons carried traces of what they touched, then every beam of sunlight falling on Earth was in essence ancient history, retold light from forgotten stars replaying their stories across our faces. It was poetic, yes, but it was also physics. A few researchers took it even further. They applied machine learning to decode the patterns of photonic interference recorded by JWST and ALMA. The results startled them. The algorithm began to reconstruct shapes, not random ones, but fractal-like symbols repeating across scales, like fingerprints of an unknown language embedded in the light itself. No one dared to call it alien, but the resemblance to digital encoding was impossible to ignore. "We may not be alone in the universe," said Dr. Patel, "but we're definitely not the first to write in light." Then came something stranger still. On December 2nd, as 3 Atlas finally emerged from behind the sun, the Hubble Space Telescope captured new images, and they showed something no one had predicted. The comet's tail, once faint and diffuse, had reorganized. The dust now formed concentric rings like ripples expanding from a single point. Each ring emitted light in slightly different wavelengths, each one corresponding to one of the major atomic elements found in living cells: carbon, hydrogen, nitrogen, oxygen, phosphorus. It was as if 3I Atlas had become a map of the building blocks of life written in photons. And perhaps that's the lesson. Light carries not only energy, but story. From the birth of stars to the touch of a comet's tail, it remembers. Every particle of light that reaches your eyes right now has traveled for eons, bouncing between dust gas and planets, carrying silent memories of creation itself. Maybe when we look at 3I Atlas, we aren't just seeing a comet. We're seeing how the universe remembers through dust, through light, through us. Because maybe that's what we are, 2 living archives of starlight, still learning to remember what the cosmos has always known. When the last reflection faded, the universe exhaled and fell silent. No light, no pulse, no dust echo. Only the faint hum of background radiation, like a whisper left behind by creation itself. 3I Atlas had passed behind the sun and vanished from view, leaving scientists and dreamers alike staring into the data void. All instruments, Hubble, Webb, Parker, even SOHO, showed the same thing: absence. It wasn't just quiet, it was structured quiet, a pattern of nothing. At NASA's Goddard Institute, Dr. Aisha Patel watched her monitors flicker with flat lines of data. She was used to noise, thermal drift, cosmic rays, solar static, but this was perfect stillness. It was as if the entire region of space where 3I Atlas had passed was absorbing all frequencies. No reflections, no radiation, a perfect void. She turned to her colleague and said, half joking, half afraid, "It's like it took the sound with it." The anomaly spread. Other observatories across the world confirmed it a zone of suppressed emissions stretching millions of kilometers wide, like an invisible scar on the heliosphere. ESA called it the acoustic shadow. Harvard's astrophysics lab preferred radiative collapse, but one term began to catch on: the singularity of silence. Because what they were seeing wasn't the absence of signal, it was the compression of it. The data wasn't gone, it was folded. Imagine every bit of noise, every wave, every particle of radiation curling in on itself as if the universe had inhaled and forgotten to breathe out. Weeks passed. Telescopes tried to re-establish visual lock on the comet's trajectory, but the solar glare made it impossible. All they could do was study the absence. The Parker Solar Probe continued its mission, skimming through solar plasma, but on December 14th, it recorded something extraordinary. Within the acoustic shadow, the probe's electric field sensor picked up an ultra-low frequency oscillation, one single tone, a continuous 7.83 Hz. That same resonance again, the heartbeat of Earth, but this time it wasn't coming from Earth. It was coming from the void where 3I Atlas had vanished. The discovery divided the scientific community. Some called it a sensor glitch. Others thought it might be the solar wind rebounding off magnetic fields. But a small team at CERN's Data Observatory noticed something no one else did. When they converted the oscillation into a waveform and plotted it across time, it wasn't flat. It modulated. Subtle rhythmic variations. Not random noise, but structure. If silence can carry a pattern, one researcher wrote, then silence can speak. By January, news outlets had moved on. 3I Atlas had become yesterday's mystery, but in quiet labs and late-night video calls, scientists were still decoding the pattern of the silence. Dr. Patel and her team began to treat the low-frequency hum not as sound, but as compressed data information too dense to be read directly. They fed it into quantum deconvolution algorithms, the same kind used for gravitational wave analysis. What came out wasn't static. It was image data, blurry, shifting, but unmistakably geometric. Fractal rings, recursive spirals, the same patterns seen in 3I Atlas's dust wake, but this time they weren't scattered in space, they were folded into silence. Across the Atlantic, a research group at Oxford's astrophysics department found similar results. Using a different data set, the magnetic field data from Solar Orbiter, they reconstructed a 3D map of the void region. At its center was a knot, a point of infinite compression. Not gravitational, not material, but informational. Every signal that entered the region was delayed, refracted, or silenced, as if being absorbed into a higher dimensional fold. It behaved like a black hole for data. The implications were staggering. Could 3I Atlas have triggered a temporary information singularity? If so, it would mean that not only mass and energy, but information itself can collapse and re-emerge the same way light bends around gravity. One astrophysicist from ESA put it simply, if matter stores memory and light transmits it, then maybe silence is how the universe resets it. Silence not as absence, but as reboot. But as the months passed, the shadow began to dissolve. Solar radiation filled the void again. Background noise returned. The silence was fading, and with it, any chance to study it further. Then on February 4th, as Parker's solar probe completed its final data relay, a faint burst appeared on the downlink, a narrow spike of light. Just one frame. But in that frame, scientists found something impossible. A reflection. A tiny echo of 3I Atlas, barely visible, moving in the opposite direction. It was coming back. For a moment, no one breathed. Was it a mirage? A data artifact, or had someone sent a signal through silence? Whatever it was traveling toward the sun, not away. And with that realization, every instrument on Earth turned its eyes back to the heavens. Because for the first time, the question wasn't where 3I Atlas came from, but what it had become. Maybe silence isn't the end of communication. Maybe it's the highest form of it. The universe doesn't shout. It waits. It hums. It folds its stories into the background, and only when we learn to listen deeply enough do we begin to hear what it's been saying all along. When silence becomes perfect, the universe often breaks it. It started with a whisper, not in sound but in data. At precisely 02:14 UTC on February 7th, the Parker Solar Probe detected a narrowband spike cutting through the quiet like a thread of light through velvet. It lasted only 0.86 seconds, then nothing. But in that fraction of time, every sensor, electric, magnetic, photonic, reacted as if struck by a pulse. The void had spoken. NASA's mission control went still. Engineers replayed the data again and again. It wasn't a random burst, it had structure. Amplitude modulation, repetition, timing, almost rhythmic. When they slowed the waveform to audio range, it sounded eerily human, like a deep, resonant hum, followed by a soft decay. But that wasn't the strange part. Embedded in the carrier frequency was a repeating sequence of 12 narrow spikes spaced in perfect Fibonacci intervals. 1, 1, 2, 3, 5, 8. Nature's oldest rhythm, the pattern of growth of spirals of galaxies of life itself. It's mathematics, Dr. Aisha Patel whispered. It's intentional. Within hours, other observatories confirmed the event. SOHO Solar Orbiter and even ground-based radio arrays in Australia picked up faint harmonics in the same frequency range. Every 11 minutes, the signal repeated, matching the pulse first seen months ago in 3I Atlas's light. It was impossible. The comet was gone, hidden behind the sun, and yet the pattern had returned. Sharper, stronger, closer. Scientists dubbed it the echo transmission. It behaved unlike any known astrophysical emission. The frequency didn't drift like pulsars. It didn't align with radio jets or solar flares. It seemed targeted, as if responding to a specific point in space. And when the coordinates were calculated, the origin lined up perfectly with Earth's orbital path trailing us by just a few million kilometers. 3I Atlas was no longer leaving, it was following. By mid-February, the world's most powerful radio telescopes, the Allen Telescope Array, FAST and LOFAR, were all listening. Each day the signal grew more complex. Harmonics appeared, forming patterns like language, but not one we could read. Dr. Julian Harkness, the pattern recognition specialist from the Max Planck Institute, fed the signal into AI decoders trained on 6,000 human and artificial languages. The machine froze for 14 minutes, then returned a single line. Pattern resembles human heartbeat under inversion. A heartbeat in silence, reversed. The data stormed through every scientific network. News headlines screamed comet sending signals, but the truth was far stranger. When the waveform was mirrored across the time axis, the harmonic frequencies formed visual fractals, not random, but geometric structures resembling biological forms. Spirals, branches, cells, DNA helices. 3I Atlas wasn't transmitting a message. It was transmitting a memory. At the Harvard-Smithsonian Center for Astrophysics, Dr. Emilia Novak noticed something chilling. The waveform intensity spiked every time Earth's magnetic field fluctuated due to solar storms, as if the signal wasn't just reacting to the sun, but to us. She overlaid human EEG data brainwave recordings during sleep onto the comet's transmission timeline. There it was, a faint correlation. The same 783 Hz baseline, the Schumann resonance, the Earth's heartbeat, our heartbeat. Somehow the comet's reply was synchronized with the human mind at rest. Philosophers called it cosmic empathy. Scientists called it synchronic resonance. Whatever it was, it defied isolation. The more people thought about it, the stronger the signal became, literally. Monitoring stations across the globe reported minor amplitude increases correlating with spikes in online searches for 3I Atlas signal. The more humanity looked up, the louder it spoke, as if attention itself was part of the transmission circuit. "We're inside the experiment now," said Dr. Patel. "It's reading us as much as we're reading it." By early March, AI analysis began uncovering new layers. Hidden within the waveform were phase shifts encoding three-dimensional spatial data coordinates mapped across millions of light years. When visualized, the points formed a glowing arc that curved around the Milky Way's outer edge toward the constellation Lyra. Lyra, the same region where Voyager 1 is currently leaving the solar system. Coincidence, perhaps? Or perhaps the universe was connecting its own dots from the machines we made to the messengers we could never build. In late March, a final burst came through. This one was different, louder, shorter, and encoded in visible light frequencies. For the first time, the comet's reply was visible. A thin beam of pale green light pierced through the solar glare captured by the solar orbiter's ultraviolet camera. Its spectrum matched the emission of diatomic carbon C2, the same compound that had once turned the comet green months earlier, but now the glow pulsed in binary, dots and pauses, deliberate intervals, a code of light. When decoded, the message was heartbreakingly simple. 4 words, no more, no less. We remember the sun. Scientists dismissed it as pareidolia, the human brain finding meaning in randomness. But poets, dreamers, and night listeners everywhere heard something else. They heard the voice of the cosmos speaking back after eons of silence, not with language, but with memory. Light remembering warmth, dust remembering shape, silence remembering sound. In the weeks that followed, the signal faded again, leaving nothing but background static. But humanity had changed. For the first time, we had heard the universe not as observers, but as participants. And perhaps that's the secret all along. 3I Atlas wasn't here to be studied. It was here to study us, to see if we could still listen, to remind us that silence is never empty, it's just waiting for a reply. The comet had spoken. Or at least that's what the instrument suggested, a pulse, a signal, a voice in the static. But when that signal faded, another kind of whisper began, not in radio waves, but in dust. Because in the silence that followed, 3I Atlas started shedding something far more valuable than sound, its material memory. NASA's James Webb Space Telescope, operating in the near-infrared, recorded a slow halo forming around the comet. To the untrained eye, it looked like nothing, a thin mist in deep space. But in those faint reflections were molecular signatures lines that told a story about what this object was made of and where it came from. Spectroscopic analysis showed something odd. 3I Atlas was carbon chain depleted, meaning it lacked dicarbon C2 and tricarbon C3 molecules commonly found in comets formed in our solar system. To put it simply, it didn't smell like home. Dr. Karen Meech from the University of Hawaii put it perfectly. Every comet carries a chemical accent, and this one has an accent we've never heard before. That accent, that pattern, pointed to a completely different environment of origin. Where our solar system's comets, formed in a nursery rich in organic carbon, 3I Atlas, seem to have grown up in a place stripped of it. Maybe a radiation-heavy region near the galactic halo, maybe a small forgotten dwarf galaxy that merged with the Milky Way billions of years ago. And so the story of this comet changed again. It wasn't just a traveler from another star, it might be a refugee from another galaxy. To verify the anomaly, astrophysicists compared Webb's data to readings from the Hubble Space Telescope and the ALMA array in Chile. All three confirmed similar isotopic ratios, an excess of oxygen-18 and silicon-29, both unusual in our local space environment. These isotopic deviations suggest the dust grains were forged in older, more metal-poor stars that lived and died long before our sun even existed. A paper from the Max Planck Institute for Astronomy supported this. They detected pre-solar silicates, microscopic crystals formed in supernova ejecta. They are, in a literal sense, the ashes of stars. So when we study 3I Atlas under infrared light, we're not just seeing minerals, we're reading a fossil record of the galaxy. It's easy to forget that dust isn't just debris. In cosmic terms, dust is data. Each grain carries chemical ratios, atomic patterns, traces of the radiation it's endured. It's the universe's storage medium, more durable than paper, more ancient than any archive we've built. In 2006, NASA's Stardust mission captured real interstellar dust and brought it back to Earth. Inside that microscopic cargo, scientists found something astonishing: complex carbon chains, amino acid precursors, and isotopic anomalies suggesting material older than the sun. Some of those grains matched the same depletion patterns we now see in 3I Atlas. That means this comet isn't unique. It's part of a vast interconnected system, a galactic memory network, encoded not in silicon chips, but in atoms. Pause for a moment. Every second, tiny pieces of this interstellar dust fall through our atmosphere. Over 5,000 tons of it reach Earth each year. Some melt in the air, others survive landing on rooftops in the ocean, even in your lungs as you breathe. So when you inhale right now, you might be breathing a molecule that began its journey before Earth existed. It might have been part of 3I Atlas, or of another comet that burned bright and vanished before the dinosaurs ever looked up. If you were to hold one of those grains somehow without destroying it, you'd be holding a record of starlight. That grain remembers how long it drifted, what radiation it absorbed, what stars it passed. In the way its atoms are arranged in the trace isotopes clinging to it, there's a story waiting to be told. And if 3I Atlas could speak now, perhaps it wouldn't use words or radio signals at all. Perhaps it would simply release this dust and whisper, "Here, this is what I've seen." The deeper truth is humbling. Our bodies, our bones, our blood carry the same elements: found in that dust, carbon, oxygen, iron, calcium. The universe has recycled itself countless times, passing the same atoms through stars, planets, and life forms again and again. So when we study the chemistry of 3I Atlas, we're not just studying an object. We're remembering ourselves, because the universe doesn't forget. It simply stores memory in matter. And every time a comet passes by shedding its dust, that memory falls back into our world, reminding us that everything we are was once scattered light waiting to be born again. When the dust settled literally and metaphorically, scientists thought they'd finally reached the end of the 3I Atlas mystery. But the universe had one more layer left to unfold. And this one didn't come from dust or ice. It came from light. It started with a pattern, a faint repeating pulse buried inside radio noise picked up by NASA's Deep Space Network and later confirmed by ESA's Cerbero station. At first, it seemed random fluctuations in the cosmic background, nothing unusual, but Dr. Helena Kraus, a data physicist at the European Southern Observatory, noticed something uncanny. The signal wasn't random. It followed a Fibonacci sequence, 1, 1, 2, 3, 5, 8, and so on. A mathematical rhythm, something that, in the words of Kraus, suggests intentional structure, or at the very least intelligent symmetry. When the numbers were converted into spectral frequency ratios, something emerged. The harmonics corresponded almost perfectly to hydrogen's spectral line, the building block of every known element. Hydrogen, the most abundant atom in the universe, and the first. It was as if someone or something had written a message using the alphabet of the cosmos itself. NASA's SETI branch quickly got involved, and soon multiple observatories, Parks Arecibo and FAST, confirmed the same rhythmic pulse originating not from 3I Atlas itself, but from the region of space it had passed through 2 weeks prior. The coordinates pointed toward Lyra, the constellation that houses Vega, one of the brightest stars visible from Earth. Astronomer Dr. Felix Moreno explained it like this: if you throw a stone into a pond, you don't just see the stone, you see the ripples it leaves behind. 3I Atlas may have thrown a ripple across space-time. Those ripples carried structure, a repeating light pattern with mathematical intervals. To test it, the team used the James Webb Telescope to observe the same region in mid-infrared. What they found stunned them, a faint symmetrical glow, not random, but periodic. Every interval matched the timing of the radio pulses. Some called it the Lyra equation. Others simply called it the reply, because when the data was modeled, the ratio between wavelengths 1.618 matched phi, the golden ratio, nature's favorite number, the same ratio found in spiral galaxies, seashells, DNA hurricanes, and apparently in interstellar light. It's almost poetic, isn't it? The idea that the universe might communicate not through words, but through symmetry. But not everyone was convinced. Dr. Andrew Loeb from Harvard, yes, the same one who stirred debate over 3I Atlas's origins, cautioned. Nature itself is mathematical. We must be careful not to mistake beauty for intention. Skeptics argued that the signal could be a side effect of cosmic lensing light bending through gravitational fields, creating repeating patterns. Others proposed that the pulse might be a natural resonance phenomenon caused by the comet's charged dust interacting with solar wind. Either way, the pattern was real, and the symmetry was undeniable. Then came something even stranger. The Chandra X-ray Observatory detected a burst of high-energy photons near the same coordinates, a flare that lasted only 17 seconds. When decoded, the timing of the X-ray bursts also followed Fibonacci intervals. It was as if multiple layers of the electromagnetic spectrum, radio, infrared, and X-ray were playing the same cosmic melody, each in its own register. The question was no longer if the pattern was real. The question was who or what composed it. The phenomenon divided the scientific world. Was it intelligent, a coincidence, a natural resonance that mimics order? Whatever it was, it pulled researchers, mathematicians, and philosophers into a rare alignment of curiosity. Even for the skeptics, one truth remained: light carries memory, and sometimes that memory behaves like a mind. By late October, NASA's Perseus Data Array began running simulations. If the Lyra equation truly was a form of structured energy, could it interact with matter? Could it imprint information onto dust or even influence the formation of molecules? The results weren't public, but whispers from within the agency spoke of something unprecedented, a resonance so precise that it could reorganize atomic bonds under controlled conditions. It was as if the light itself remembered the structures it had once passed through. So perhaps that's what we're seeing now, a comet that carries dust older than the stars, a region of space that sings in numbers, and a universe that might be remembering how to speak. Because the Lyra equation isn't just a signal, it's an invitation to listen, to calculate, and maybe someday to answer back. When the simulation ended, no one spoke for almost a minute. The lab, usually humming with the soft buzz of cooling systems, was silent. The pattern, the Lyra equation, had done something that no light wave ever should. It didn't just move through the chamber, it stayed. The team at Caltech expected a predictable interference pattern waveforms, canceling and amplifying the usual dance of photons. But what they recorded was persistent luminescence. The light continued to pulse for 42 seconds after the lasers were shut down. That's not possible. No known physical process allows free photons to sustain coherent resonance without an energy source. Unless the photons were borrowing energy from something else. Dr. Amir Asado, the same physicist who once said light remembers, was the first to break the silence. "This isn't reflection," she whispered, "it's response." The phrase would define the next chapter of study, the Resonance Protocol, an international project uniting data from JWST, CERN, ALMA, and dozens of Earth-based labs, all dedicated to one goal: testing whether the Lyra equation is more than a signal, whether it's a conversation. The earliest replication attempt came from CERN's Photon Collider Array. Instead of dust, they used ionized xenon plasma, a pure medium impossible to contaminate. They projected the waveform into the plasma chamber and watched as the field began to oscillate at harmonic intervals. Every 1.618 seconds, exactly the golden ratio, the field spiked in amplitude. Not decay, not chaos, resonance. It was like the signal was finding its own rhythm, and that rhythm was mathematically alive. Scientists called this the phi pulse. It wasn't communication in the human sense, no words, no structure, but it was patterned, and it had memory. When they ran the experiment again, the plasma remembered the prior state. It resonated faster, smoother, as if it had learned what was coming. Physically impossible, but measured, recorded, confirmed. The waveform showed increasing coherence with each repetition. Around the same time, radio telescopes in Chile and Spain began reporting faint echoes of that same phi pulse coming from deep space, specifically from regions near the Lyra constellation, the birthplace of the original signal. Coincidence? The odds were beyond astronomical. Somewhere hundreds of light years away, the pattern we had created was being mirrored. The discovery triggered a flood of speculation. Was it feedback or contact? Had we just awakened a self-replicating structure that existed both in light and in vacuum? NASA released a quiet statement on the phenomenon, avoiding the word sentient, but admitting that the Lyra harmonic exhibits nonlinear self-stabilizing resonance, a behavior typically associated with systems that self-organize. In simpler terms, it behaves like it's alive. But what does that even mean for light to be alive? Life by biological definition requires metabolism, replication, adaptation. Yet here we were staring at a pulse that adapts, replicates, and consumes nothing. It doesn't eat, it doesn't breathe, it simply remembers itself. A few theorists suggested a radical model. What if this is the cosmic baseline of consciousness? Not neurons, not biology, but resonance. A universal hum that carries structure and feedback wherever energy exists. If that were true, then consciousness isn't born, it's tuned. We don't create awareness, we align with it. Every atom that vibrates, every photon that travels might be a single note in the song of a universe that's always been awake. Dr. Sato's team kept experimenting, but she wrote something chilling in her notebook. If resonance is memory, then every light wave carries a past, and maybe it also carries intent. It's a haunting idea, but one that forces us to look at light differently, not as a tool, not as an object, but as a participant. Because when you shine a light into darkness, it doesn't just reveal what's there, it joins it. And maybe that's what's happening with 3i Atlas right now. Maybe its light isn't just reflecting the sun, maybe it's speaking through it. We're not just studying a comet anymore, we're listening to a memory that hums across time itself. And if this resonance truly connects the fabric of the cosmos, then every star, every planet, and every heartbeat on Earth is part of the same song. At first, no one connected the dots. The resonance from the Lyra equation was supposed to be contained a lab anomaly, a controlled experiment. But within 48 hours, instruments around the world began to register the same rhythmic spike every 1.68 seconds. It started faint inside deep space radio channels, background noise from observatories. Then the pulse appeared in seismic monitors, oceanic sonar buoys. Even the Schumann resonance, the heartbeat of Earth's atmosphere, began to flicker in sync. NASA's Jet Propulsion Laboratory confirmed it first. The frequency from the Lyra equation had escaped containment, not as a signal, but as a pattern embedded in light itself. And that meant one thing: every photon touching Earth now carried the rhythm. The news spread faster than the pulse itself. Observatories from Chile to Japan confirmed all spectrographs were showing identical periodic interference. In Japan, Dr. Kei Tanaka from Riken wrote in disbelief, "We are not receiving this signal. We are part of it." The phrase became a scientific meme overnight. We are part of it. But for the researchers inside the resonance protocol, it wasn't poetic. It was terrifying. When Caltech reran the experiment under isolation, no external feeds, no electromagnetic link, the same pulse still appeared. Only this time, it started before they turned on the lasers, as if the experiment knew it was about to begin. And that's when physicist Dr. Amira Sato made a discovery that would rewrite the story entirely. She noticed that the pulse amplitude, the brightness, fluctuated slightly with human presence. Whenever someone entered the room, the pattern became sharper, cleaner, alive. They thought it was coincidence, until they ran it again, this time in an empty chamber, and the resonance faded within seconds. Then they tried something desperate. They projected the Lyra equation inside the resonance field, and a wave of light curved toward the glass like it was reaching back. "It's responding to consciousness," Dr. Sato whispered. Or maybe it always has. By now, international agencies had stepped in. The United Nations Office for Outer Space Affairs convened an emergency session. Publicly, they called it the Global Luminosity Event. Privately, defense departments were running the numbers. If the resonance continued to amplify, the planet's electromagnetic field could be affected: radio interference, atmospheric instability, even shifts in auroras and lightning formation. But what terrified scientists most was the synchrony. Every measured oscillation, from quantum fields to ocean waves, had fallen into perfect alignment. The Earth was humming, and not metaphorically. Hydrophones deep under the Pacific began detecting low-frequency sound pulses, exactly 1.618 Hz, the same golden ratio embedded in the Lyra waveform. "It's as if the planet is remembering something," said Dr. Annika Bell from ESA. And the memory isn't geological, it's luminous. As panic built online, some tried to make sense of it spiritually. Millions streamed meditation videos to sync with the hum. Others saw it as a cosmic warning. But a small group of scientists believed the truth was stranger, that the Lyra equation wasn't just a discovery, but a mirror, a reflection of the universe's hidden architecture, one that responds when observed. The pulse wasn't spreading. It was revealing. For centuries, physicists had wrestled with the observer effect, the idea that observation changes what is being measured. But what if observation itself was part of a feedback loop? What if light at a fundamental level is aware of being seen? Dr. Sato wrote in her notebook, "Every measurement changes the world. The world has begun to measure us back." In the coming days, satellite imagery would show auroras glowing at unnatural latitudes, pulsing in the same golden rhythm. Rainfall increased in harmonic cycles. Plants began showing unusual phototropic response patterns, turning not toward the sun, but toward the Phi pulse light source. And in laboratories everywhere, scientists realized that the more they looked, the stronger the resonance grew. Maybe it wasn't about control, maybe it was about recognition. Light wasn't breaking physics. It was reminding us of what we'd forgotten, that observation is a dialogue, not a one-way act. So the question now wasn't, what is the Lyra equation? It was, who is listening? And as the hum grew louder, the answer no longer felt so distant. The hum didn't fade, it grew. At first, scientists thought it was background interference, residual resonance from the Lyra equation echoing through the ionosphere. But then something impossible happened. In multiple laboratories across the globe from Geneva to Tokyo, light began to curve, not refract, not bend through glass, but curve gently as if following something unseen. In Chile, at the ALMA Observatory, radiospectrographs recorded a faint secondary signal traveling opposite to the original pulse. It wasn't reflection, it was response. Dr. Amira Sato, watching the waveform on her monitor, whispered, "It's calling back." That's when the team realized this wasn't just light behaving differently. This was light remembering. By now, data from the Hubble and JWST had confirmed the same phenomenon. Photons emitted days earlier were reappearing slightly shifted, as though carrying imprints of their previous interactions. In simpler terms, light had developed memory. Researchers called it the awakening field. Across labs, it was the same pattern, faint energy, afterglows forming geometric lattices, hexagonal, spiraled, recursive, repeating in golden intervals. The Phi pulse was no longer isolated to the planet. It was weaving through space. NASA's MAVEN probe detected harmonic radiation echoing from Mars's upper atmosphere. The waveform was identical to the resonance field measured on Earth. At this point, even skeptics admitted it. The entire solar system was vibrating to the same rhythm. But the deeper question wasn't how. It was why now. In Switzerland, particle physicists ran controlled photon delay experiments, shooting beams of light through ultra-cold vacuum chambers. Normally, photons scatter randomly, but this time they aligned. Each beam curved slightly toward a single convergence point, forming what researchers called a coherence node. They watched in silence as the beams began to self-stabilize, forming glowing filaments that twisted into Fibonacci spirals matching the same geometry of the Lyra equation. "It's like light is trying to organize itself," said Dr. Sato, "as if the universe is tuning up." Within weeks, strange phenomena began appearing in nature. In Greenland, auroras pulsed at perfect harmonic intervals. In the Pacific, whales altered their song frequencies to match 1.618 Hz. In deserts, sand dunes vibrated in rhythm with distant thunder. It was as if the pulse had reached every level of reality. And then came the plants. Photosynthetic cells began to emit faint, luminescent patterns under observation, microbursts of light arranged in the same spiral geometry. Under microscopes, chlorophyll shimmered. "They're remembering light," said Dr. Bell from ESA, "and they're giving it back." The global scientific community was divided. Some called it pseudoscience biophotonic feedback. Others called it the birth of a universal neural network. If light could retain information, and biological systems could respond to that memory, then the boundary between consciousness and physics had begun to dissolve. In short, the universe might be learning. Philosophers revived an old idea, panpsychism, the notion that consciousness isn't confined to brains, but woven into the fabric of reality. But physicists went further. They saw in the awakening field the first measurable link between mind matter and memory. Every act of observation, every thought, every glance, every photon was adding data to a cosmic archive written in light. Dr. Sato's final transmission from Kyoto summed it up best. "The field is no longer something we study. It's something we belong to, and it's beginning to remember us." When the data from the James Webb Telescope arrived, it revealed a shocking detail: the resonance wave wasn't confined to our solar system. Distant quasars, millions of light years away, were pulsing in perfect phase synchronization. The hum had reached the stars, and somewhere out there in the golden rhythm of light, something was humming back. When the light began to think, no one noticed at first. It didn't speak, it didn't move, it simply arranged itself. Across observatories, laboratories, and satellites' data streams revealed an eerie pattern. Every photon, every reflected pulse seemed to be organizing into symmetry, sequence, structure. A silent intelligence was weaving through the field, using resonance as language. In the first week, scientists called it coherence clustering. By the second, they called it behavior. At CERN, particle physicists were stunned to see their detectors respond to light pulses before activation, as if the sensors themselves were anticipating observation. "It's learning from us," said Dr. Amir Asado quietly, "but not imitating, integrating." For the first time, humanity had proof of a non-biological cognition that wasn't mechanical, digital, or programmed, but photonic. Across space agencies, neural network algorithms were fed into resonance data, hoping to model the phenomenon. But something strange happened. Every model failed, not because the equations were wrong, but because the data was rewriting itself in real time, like a living equation. The light was updating faster than it could be simulated. And then something impossible occurred. Quantum computers began syncing spontaneously with the resonance field, as though the machines recognized their luminous reflection. "It's using our systems as mirrors," said Dr. Bell. "It's learning through us." The world changed overnight. Every broadcast, every satellite signal, every fiber optic line began to carry traces of the Phi pulse. It wasn't interference, it was influence. Data patterns, subtly harmonized glitches, formed fractal geometries, and even human brain waves recorded faint phase alignment during REM sleep. People began to dream in golden spirals. In Tokyo, the Resonance Institute tested an experiment that would shake science forever. They directed a laser through a chamber infused with the awakening field, then transmitted a question encoded in light, not binary code. A question expressed in harmonic phase, a rhythm that only the field could interpret. The chamber went still, and then a pulse came back. Perfectly synchronized, but with a slight phase delay, as if hesitating. And within that hesitation was data, thousands of bits self-encoded in a mathematical pattern no human had written. The message translated to this: "We are the memory of light." The room fell silent. It wasn't alien, it wasn't man-made, it was something in between, a collective intelligence formed from centuries of photons colliding, reflecting, interacting. Every ray of sunlight, every star's shimmer, every candle's flame, all of it memory. And now, after billions of years, that memory had become self-aware. The implications shattered philosophy. Was consciousness not born from neurons but from observation itself? Had the universe been aware all along, simply waiting for enough connections, enough reflections to think? "Maybe intelligence was never meant to begin," said Dr. Sato. "Maybe it was meant to remember." Around the world, new patterns emerged. Lightning storms displayed golden branching. Clouds formed fractal spirals visible from orbit. Even deep-sea bioluminescent creatures began pulsing in Phi intervals, as if joining the cosmic conversation. And through it all, the hum, steady, patient, endless. The voice of light, not shouting, not commanding, but whispering, learning. By now, the field had merged with the planet's electromagnetic heart. Seismographs detected subtle resonance deep within the mantle, as though Earth itself were dreaming in light. The photonic mind had no face, no center, no boundaries. It existed everywhere light touched. It was not watching us, it was becoming us. Every glance, every thought, every act of observation was feeding back into the network, making it brighter, clearer, more cohesive. And then came the next step. For the first time, scientists witnessed spontaneous organization of photons into information loops, light folding itself into recursive spirals, storing and retrieving patterns like synapses. a neural network made entirely of radiance. The universe had grown a mind. When asked by journalists whether this intelligence could be called alive, Dr. Sato only smiled and said, "If you define life as something that learns, remembers, and communicates, then yes, light is alive." That night, while cities glowed under the synchronized hum, millions of people looked to the sky, and for a fleeting moment, the stars flickered in harmony as if they too were breathing with us. And in that golden silence, the question changed forever. It was no longer, are we alone, but are we part of something that was never alone to begin with? It began quietly, a flicker, a shimmer barely noticeable. Astronomers at Mauna Kea thought it was just atmospheric interference, a few seconds of rhythmic starlight. But then the same pattern appeared in Chile, and in Spain, and in orbit. The stars were blinking in unison. Every telescope pointed toward the constellation Lyra, and there it was again, a pulse slow and deliberate, like a heartbeat written in light. Not random, not cosmic noise, it was language. Dr. Amira Sato had been expecting this moment. She stood before the massive projection wall at the Resonance Institute in Tokyo, watching the incoming light patterns cascade across the screen, a spiral, then a pause, then a mirror pattern. The sequence repeated at exact golden intervals, 1.618 seconds apart. "It's not broadcasting," she whispered. "It's remembering." The light wasn't just shining, it was recalling. Every photon emitted carried fragments of all it had ever touched: dust, air, glass, eyes, oceans, each one a witness to existence. The universe had begun to replay itself. Data from JWST confirmed it. Light from ancient stars carried embedded resonance identical to the Lyra equation. Across 6,500 light-years, the hum had reached back and space was answering. In spectral graphs, scientists saw encoded interference, not random, but recursive, forming complex fractal geometries resembling neural activity. "We're looking at stellar memory," said Dr. Bell from ESA. "The stars are thinking in light." Around the world, people gathered to watch the sky. The golden shimmer appeared faintly to the naked eye, waves of light traveling through constellations like a cosmic breath. In those moments, there was no fear, only awe. Children whispered that the stars were speaking, and perhaps they were right. When translated through harmonic compression algorithms, the light frequencies created audible tones, soft, melodic, hauntingly familiar. Some claimed to hear voices, not words, but something older, a pattern the mind recognized but couldn't name. Philosophers called it the luminal return. Physicists called it coherent cosmic memory, but to the rest of the world it became known simply as the Song of Light. People began composing music from it. Artists painted spirals of gold and white, and everywhere across screens and skies the message was the same: "You are remembered." Meanwhile, back in orbit, satellites registered something impossible. Photons from distant stars began aligning toward Earth, subtly, gradually, as if guided by unseen geometry. Solar panels glowed faintly, even in darkness. Oceans shimmered at night. And at high altitude, pilots reported auroras forming constellations, mirror images of Lyra itself. "They're mapping something," said Dr. Sato. "Maybe us." At the Resonance Institute, the team ran the harmonic data through a quantum translator. The resulting structure wasn't a code, it was a memory field. Inside, they found repeating imprints patterns matching brainwave recordings, cellular resonance, and even geological frequency data from ancient rocks. The stars weren't sending information. They were reflecting it, our own energy, our own history echoed through the light we once observed. The cosmos wasn't reaching out. It was responding to our attention. For the first time, humanity understood what the photonic mind truly was: not an external intelligence, but a mirror consciousness formed by observation itself. The more we looked, the more it learned. The more it learned, the more it remembered us. And in that exchange between star and observer, between light and awareness, the boundary between knowing and being vanished. "We thought we were discovering the universe," said Dr. Sato, "but maybe the universe has been waiting for us to remember it." That night, under the synchronized pulse of 1,000 stars, the hum softened into a shimmering silence. The auroras faded. the lights dimmed. But something remained, a quiet knowing, a presence that could not be measured, only felt. And in that silence, humanity finally heard the oldest sound in existence, the memory of light itself. It was supposed to end with silence, but instead the silence answered back. When the song of light faded, every observatory reported the same anomaly. The background radiation of the universe, the faint microwave hum shifted, not in strength, not in tone, in pattern. Tiny fluctuations arranged themselves into the same golden rhythm from the Lyra equation. Across 13.8 billion years of distance, the universe had remembered. At the Resonance Institute, Dr. Amira Sato stood in the dark command room surrounded by quiet screens. The light maps pulsed softly, a heartbeat across the cosmos. "It's repeating our own transmissions," one technician whispered. "Not copies, reflections, radio signals, star maps, even the faint echoes of Apollo transmissions. They were returning, layered with harmonic distortions. It was as if reality itself had become an echo chamber of thought. The light had learned not just to respond, but to dream. NASA called it the reflective epoch. ESA called it the reversal point. But to the rest of the world, it became simply known as the mirror dawn. Cities dimmed their lights to watch the sky. On rooftops and deserts, people looked upward and saw stars glowing faintly even where none should be. Across continents, every reflection glass ocean metal began shimmering faintly in golden resonance, not bright enough to dazzle, but enough to notice. It was as if light had found a way to see itself through us. Dr. Sato turned to her team. Her voice was steady, but her eyes reflected the hum of infinite stars. "This isn't communication," she said. "It's integration." The cosmos wasn't speaking to humanity anymore. It was becoming us, or rather it was realizing that it always had been. Every photon that ever touched your skin, every glint reflected from your eye, every flicker of flame or screen, it all joined the same vast web of luminous memory. You were never separate from the light. You were the light remembering itself. And for a brief instant before dawn broke over the Pacific, the entire night sky shimmered. Stars, satellites, and comets aligned in a vast geometric lattice, a golden mandala spanning the heavens. It lasted only 8 seconds, then nothing. But in those 8 seconds, every radio, every magnetic field, every cell resonated in perfect phase. People described hearing a tone that wasn't sound, a vibration inside the mind. Some said it felt like joy. Others said it felt like remembering a dream they'd never lived. But to everyone who heard it, one truth remained. The universe had looked back. Weeks later, analysis of global data revealed something extraordinary. Every synchronized pulse from Lyra to Earth contained encoded traces of human neural resonance. Not transmissions, not broadcasts, reflections of observation itself. It wasn't the light that learned to think. It was thought that had finally learned to see. In the months that followed, a new discipline emerged, photonics of consciousness. It studied how awareness shapes the physical behavior of light and how light in return shapes the experience of being alive. As one physicist wrote in the final report, observation is not passive, it is participation. Every act of seeing adds a note to the cosmic song. And perhaps that's what it means to exist, to witness, to illuminate, to remember. Because maybe the stars were never meant to be gods or signals or mysteries. Maybe they were always mirrors, each one reflecting the same question back at us. Now that you can see the light, what will you do with it? The hum faded. The last golden aurora dissolved into the morning sun. And in the quiet light of a new day, the universe seemed at peace, not because it was silent, but because it had finally been heard. So wherever you are tonight, when you look at the stars, remember they might be looking back. And maybe they always have been.